Hello, and welcome to more of me learning Haskell and then streaming it on the internet. I missed last week because I was off on holiday in the Welsh countryside. So I'm very relaxed now. It was a lot of fun, but coding is also fun, so it's good to be back to this. Last time out, I was looking at the error handling inside each step of the VM, and I got to a pattern where I could write out the steps I wanted. Well, not the steps, but I could write out the implementation of the step in a pretty readable way, I think. And then I could use throw error or just return left an error if there was a problem. And I got it working for a few steps, which is cool. So the plan for today is to basically finish that refactored. So to take all of the steps and write them with that signature where they return either an error or the updated CPU. And maybe fill in some tests as I go, and then if I have time to go back to the original problem, which was trying to get call and return to work, and see if I can debug it when I have some more readable code this time. Okay, so jumping back into the code. I have the step prime, which is the thing I was working on. I think, well, there's a run prime as well. So run prime is the same as run, but it just calls step prime rather than calling step. And step prime is where I started to call these new functions where we are returning either a new CPU or returning an error. And then we return an error, then we just stop processing and we set that error. When we stop processing, just go up a little bit, it should stop. CPU will be halted at this point, so it'll stop looping and then get the error back. One thing actually I wanted to do at the end of last week but didn't get around to was CPU error is a string, or maybe a string, and actually I think it should be maybe a VM error. What's the type for this? Maybe, can I find it? Maybe a VM error, one of these. And then we can show it slightly differently. Or we can show it later, I guess, at this point. But that would just make this typed. Oops. All out. So I'll make that change. That'll probably break a lot of stuff, so I'll have to go and fix all of those. So run traced. So it's just error. This should be show error. When we're running, it'll be a similar problem. So, oops. Down, oh, I think the dollar in there. Down here, when we have this error, it will just show it. And there's a similar thing here, I think. That was surprisingly pain-free. Here it's just error instead of showing the error. And then it says there are 4 more errors. Where are they? Okay. So in the old functions, which I haven't changed over to either types yet, we can't set these. We can't set these strings basically coming back from the old implementation of pop. So I can get rid of this because step prime does everything I need it to do. So that should be easy. And then I'll go back up here and just get rid of this from step. Okay, and then finally down here. Okay, so binop is returning a string, it seems. Yeah, rather than a VM error. It's going to take a while. So this was a VM error. VM error is in this file, isn't it? No, it's in a thing called VM errors. So this is not enough elements on stack. I guess that's stack too small. Is this used anywhere? Nope, doesn't seem to be. I'll just check that. Jump to works, so empty stack is definitely used. Yep, cool. So I'm not going to call it stack too small. I'm going to call it not enough elements on stack. And then here I can say not enough elements on stack. Okay. One error left. So we go back to VM. This one now works. The error returning is the correct type. I'll change this in a minute to return either. What's my error? Okay, unexpected instruction. So in the VM errors, I can put unexpected instruction. And I'll just jump to there. Oops. I will put unexpected instruction. Now we have 0 errors, which is good. I'm just going to check it works. So I just go back to my spec and run one of the specs. Like a whole bunch of specs are broken. I just want to make sure it compiles. Yeah, that's tests are broken because I'm now checking against strings. Okay. It wasn't this file. So not this file. What file was it in? Not that one. It's in stack spec. Okay. So here, it's not going to be that. It's going to be not enough element on stack. And this one should be right stack 3, no instance for equal VM error. Oh, interesting. So I need to be able to compare errors to make sure the right one comes back. Okay, next. Oh, we can ignore this one. Okay, let's try running the test again. Just make sure it compiles. It does, but it runs forever because of some problem. Let's kill that. Okay. Back to the VM spec, I guess. Can't remember whether or not this was running in the last week. I'm guessing not because it's not running now and I've just renamed some stuff, but how do I make it run again? Which ones are broken, I reckon? I think there is a way to run a single spec, but I can't remember what it is. Can I jump? No, can I jump there? So we're looking at each spec, run single spec. really not helpful. Minus m and then some path to it. Okay, so I need to know what the path to it would be had it worked. So, do I run Haskell? I do. Say test spec. Can I run just my single spec, which is VM spec? Nope, I can't use run Haskell. Can I? Oh, that wasn't what they said, was it? It was. No, it was spec.hs. Okay, so Cabal exec, is that a thing? Cabal run. I don't know how to do this. VM spec.hs, it's in the spec directory. It's in the test directory. Nope. Can I pass arguments to Cabal test? I've tried this before. Oh, there's a lot of options here. Doesn't look like it. Okay. I'm not sure which one is failing. Let's see if it's one of those. Professional software developer approach. Delete stuff and see what happens. Okay, it was one of those. I'm a professional. Okay, it just works. It's probably the one that doesn't work. Oh, that was not the one that doesn't work. Okay, interesting. But it should be returning errors, so they should be okay, I think. It was run. So that would mean it's this one is problematic, I think. Yep. Okay, so if we call what's it doing here? We're pushing 2 into stack and then we're calling return. So the stack should try and go to instruction 2, which is this, but return should fail. I think this is what it's saying. So before we even get there. How does that work? So we're in step prime and we should be in step ret, I guess. So we call pop, it should be popping off value 2, and then we call return. which is a jump. And then a pop. Okay. And the jump is saying position here is 2, is that right? So return pointer and stack, and the pointer is the current stack pointer. Right, okay. The current stack pointer will be set to something. Did we initialize this to 0 or something like that? Yeah, we initialize it to 0. Okay, so the stack point will go back to the beginning. So we follow this through again. So clean this. So the code is saying push 2 and then return. So that's my program. So when we push 2, then the stack will contain single value 2. The stack pointer is pointing to there. By the time we hit return, the instruction pointer is pointing to the return instruction. Okay, so that's what the code says. And then in the implementation of this, so the first thing we do is we call pop and we get the result back. Okay, so pop will take this 2 out. So our stack is now empty. And value 2 is just stored in some variable. Okay, so that's the first instruction. And then the second thing we do is we call return, which calls jump. It's a pointer, and the pointer is stack pointer, which we know is 0. We give it the stack as well. So jumping to 0, S is less than P. That makes sense. Sorry, S, the length of S is greater than P because P is 0. Oh, but it's no. Stack ought to be empty at this point. So we should be getting invalid stack position. That's what should happen. And then we wouldn't pop. So here we should be returning invalid stack position, which means that here we should just be halting. But that doesn't seem to be happening. Okay, so back to the spec. So we call return its own, we get empty stack. If we call it here, it's looping forever. So what would cause it to loop forever? I mean, the thing that would obviously cause it to loop forever is until. Which is up and run. So until halted, do this. try and fix my tracer, I guess, see what's happening. So run trace. Yeah, step prime. I might just let it go, see if it works. What does run trace return? It returns the whole CPU, and run returns the result. Okay. No, this was show. Oops. This was show I was string arising from use of should be. Okay. So run trace returns an IO string, whereas run just returns a string. So I need to say something like result is vm.runTrace, and we go to program. And then we can say result should be empty stack. Okay, I'll try running this and see if we can work out where it goes wrong. It should be pretty obvious at some point. Doesn't print anything. That's interesting. Okay. So run this on its own doesn't seem to be doing anything. Let me just I want to run this on its own. What are we doing here? So we come in here. If the CPU is halted, we print the CPU and then we print the result. Otherwise, we print the CPU and we step in the CPU and then we recurse. So we should be printing something out with run trace. I mean, I could just not recurse for a second. Oops. No. This no longer loops, which means we never actually used the program. Bit meaningless. Okay, so errors if the stack does not contain a return address. And now we get error back from this. So it says expect empty stack, but got left popping empty stack. And does it run? Does it print anything? Seemingly does not. Oh, here we go. It does print just up here. So an empty stack and 2 zeros. Expected empty stack. Got left popping empty stack. Kind of confused as to how it got this, given I didn't run it, I don't think. Because the definition run trace now just prints it. Very confused. Makes no sense to me. So there shouldn't be an error, there shouldn't be anything happening with my CPU. Let's do one step. There this time is expected empty stack, but was successful. So we've done the first instruction, which is pushing value 2 on to there. Okay. So I'm now going to get rid of the return for a second. Oh no, hang on, return's important. It's the next instruction. Okay, so when I do the next instruction, it's looping forever for some reason. So we're not getting the CPU halted. So step prime says if we get an error back, then we set CPU halted to true and we set the error, and that's it. Okay. So is it possible, well, it's obviously possible, but in the stack, is it likely that this is broken? So we set this to be just something like left, oops. I can't type, invalid stack position. I'll just get rid of these for a second. Okay, so now we're going to call return, and it's just going to return the error. So I am hoping very pedantic compiler. I'm hoping that it will fail and returns error if the stack does not contain return address. Cool. So we are returning invalid stack position. Okay, so put jump back in again. It might be my use of bind. It might not do the thing that I expect in this case. So I will jump to position P in that stack, and then I won't pop. Okay. it wants int stack in the successful case. So I can say something like, I think I can say 1 comma, actually probably comma 1. Legal tuple section, use tuple sections. Couldn't match type stack with int. Okay, is it that way around? It is. Do I still need tuple sections? I do. Okay. So this is never going to be used, it's just to keep the compiler happy. But I think jump is going to return an error, which means that when we try and join the result of jump, which will be the stack, to my int, it won't do anything because I think it should be left error. That's what I think is going to happen. Let's find out. Okay, so now I have an unrecognized instruction 2, slightly more information. Does that mean? Okay, so that's interesting. The 1 in this case is the instruction pointer. It's basically where to put instruction 2, and if I put instruction pointer back to 1, let's get rid of this chip for a minute. I've kind of hard coded it so that when you call return, the instruction pointer gets to there, and then it tried to execute it again and it couldn't because it doesn't know what that means. There's no explicit halt in here, but that shouldn't be a problem because it shouldn't work. So that would suggest that this isn't happening. Oh no, it's not happening because at this point the stack should be empty. So we should be getting here, but we don't seem to be. So maybe it's slightly different. So when we call step ret, just, oh, for fuck's sake, pocket is back a new stack. Amazing. And that's what we pass into here. Right, okay, so now the stack should be empty. Yeah, that error's gone away. Okay, wow. That was a fun one to track down. So now we can, what can we do? Back in stack, we can restore the behavior of return. So I can get rid of this and replace with that. So we take the stack and we give it to pop, and pop returns a value in the remaining stack. Okay. And see that still works in the same way, doesn't loop forever. That's cool. Okay. And then in the spec, instead of using run trace, we can use run prime. Program. Just make sure that still works, but the tracing shouldn't make any difference. Okay. good, I think. So return just works. It does not just work. So we expected 5, but we got empty instructions. So what should happen here is we say call return address 3, 0, 1, 2, 3. So what I think should happen, I think this 3 is wrong incidentally. I think what should happen is that we should 0, 1, 2, 3. Screen shall shows the tablet. Sorry, didn't press the button. Thank you for that. Oh, you'd have missed all the great coding. The error was that I was ignoring the return from pop here, and I was passing the original stack into here, which means that we hadn't popped anything off the stack. The stack was still the original stack, so it had a value in it, which is not correct. So what we actually need to do is we pop the first value off, and then we'll store the new stack, and then we pass it into here, into there as S prime. Okay, so back to this. It just works. It did not just work. First instruction, VM call, then the value 3, which is place to call, so 0, 1, 2, 3. Then we should push 5 onto the stack. It should be good. Then we should return. And what I think return should do is it should be able to get the return address, which we must have pushed onto the stack somewhere. I can't remember where I pushed it onto. I think what happens is when I do the call, I push the return address onto the stack. So return address at this point should be 3, I think. Then we do the call, hit return, we pop the stack for return value, which is 5. We return to here. We return to. We move the stack back. So this is a program, not the stack. Move the stack back. It should then be able to pick up the return address. Then it should jump to that return address, which should be here, value 3. And then it should halt. Okay. So we can say result is run trace our program. It's not in scope. VM.run trace program, and then we can say result should be 5. So it should be 5, but it gets unrecognized instruction 2. It's really interesting it's unrecognized instruction 2 because I can't see 2 anywhere unless 2 is the position it was at. 0, 1, 2. Ah, no, that's the return address. Looks like it's trying to execute the return. So let's have a look and see what it printed out. So I should maybe print out the instruction as well. But anyway, empty stack, stack pointer, instruction pointer both set to 0. Still an empty stack, everything set to 0. Interesting. What's it done then? as there's nothing. Some definition of call. Oh, I haven't implemented call. Right, that's why. So in my new run, my new step prime, I haven't got call. So I can say, or instruction is, if the instruction is call, we're going to call step call prime p in CPU. So step call. I might just make the step call prime. Then we can say it goes from, it takes a program CPU and it's going to return either a VM error or a CPU. And then it can return just the CPU. It's going to return write of CPU. Okay. Where instruction pointer to call address, that should be okay. The call address should be the next value. The new stack pointer. So I'm going to look up and see what s.position does. And the new stack. So the return address is the current address plus 2. I'll put it on iPad. I'll try and remember to take it off iPad when I'm done. There's an easier way to clear, but I didn't remember that. Clear. Okay. So what do we have? What do we have here? We have an instruction which is call. So that's our first instruction. And then the address to call, which was 3. Then we got halt. Then we had push. This was actually instruction 3. And then value 5. And then return. Okay. So inside call, what are we doing? So we work out what the call address is. And that's just looking that up. So 3, which means that the instruction pointer is moved to there. Okay. Then we work out new stack position. I need to check that, but essentially it should be 0 because this is what our stack looks like at the moment. The return address is the CPU ID, so it's currently there at 0 plus 2. So this should become a return address. And the stack, it takes the current stack and it pushes the return address onto there. So return address will be 2, and that's our stack at the point at which we do the call. All looks sensible. Then for returning, we pop the value out of stack. So we've called our function, it pushes 5 onto the stack, and then it hits return. So our return value becomes the top element in the stack. So we're going to move that 5 out, and we're going to store it temporarily in some variable. And then we call this return function. and that says jump some integer on the stack, and that's the stack pointer. So I think the stack pointer should have been 0. Doesn't line up. Stack pointer is position of, oh, sorry, the stack pointer is the position of the new stack. So it should be 1, because new stack has got something on it. Okay, back into return. So it should be return 1 in our new stack. So here, stack is of length 1. Stack is length 1, and position is 1. I guess it's not going to be greater than p. So let's hope it's 0, but it might not be. It wouldn't be, because this position is going to be length, right? So our stack is empty, we push return address onto it, and our stack position is 1. So it's pointing beyond the last element in the stack. So we've got the current stack and it's saying the position after that. And then when we call return, this is saying, I think this is going to fail. I think it's going to say in the stack position, because it'll say we have an element in here. One element. If 1 is greater than 1, which it's not, then we return goodness. Take the top element off the stack for some reason, and then we truncate everything before it. Oh, this might be a problem, this result thing. This whole thing's a bit nonsense. So what happens here? Point at which we call it. Return address is set to 2, we push that onto the stack. Then we do our other instructions, so we will push 5 onto the stack. And then we hit return. The first thing return does, it takes the 5 off. So that comes out, there's nothing in this position. Stack length is 1. Stack pointer is 1. That's the other slightly confusing thing. The stack pointer is here. I think I've actually conflated two ideas in my jump, because what I think I want to do, if that is the case, then the thing that was in here gets put into some temporary variable. The stack pointer should have been here, and we should jump to here. So what we should do is we should drop anything after the 2 and then put the 2 back on the list I guess looking at the code. So it's saying if there's something on the stack, then truncate the stack. So drop elements off the stack. I'm actually working the other way around in Haskell because it's a list. So although I'm drawing it, as 2 followed by 5, what actually happens in the Haskell in a standard list is you get 5 at the head of the list, and then the next element of the list is 2. So that's what the drop is doing. It's dropping everything up to this position. That's why. That's maybe why this is happening. So what it's saying is if we have something on the list, then we drop everything up to that position. So if we had something like, if our list was this, so 3 is the oldest element, and then we push 2 on, then we push 1 on. What the code seems to say is if you have this, I don't know why we want to keep the last element, but it seems to be doing that. And the stack pointer is, let's say, here. What we do is we take this value 1 off the list, then we drop the difference, so the current size, which is 3, minus the previous size, which let's say is 2. So we drop one thing off the stack, and then we put it back on again. That makes no sense. So I think jump should just jump. So we give jump a stack pointer, which is going to be, in our case, it's going to be 1 because we have one thing on our list. And I think all we want to say is I might flip these around a bit. So if we jump to an empty list, that should be left empty stack. Do we have something for an empty stack? We have an empty stack. Okay, cool. So if we try and jump and the stack itself is empty. Oh, I can't do that. If I jump and it's stack, oops, with nothing in the list, then we say left empty stack. Otherwise, we know there's something on the stack. We don't really care what it is. If our current stack is greater than, I think it should be greater than or equal to P. So the size of our stack is at least as big as the place we're trying to drop to. So we could completely empty it, in theory. Then we just truncate the stack by dropping things off the front of it. And otherwise we're going to jump outside of our stack. things that we want to pop straight afterwards. So I guess that's why I had this check in place. So I think my P is set to be too high now. My P is too high. So it's not the position of the new stack, it's position of the old stack. So the stack without the return address on it. I'm just going to run it and see what happens. Okay. Step call. Should be step call prime. Oh, I needed to remove that. In the VM, I deleted step call together. I've only got step call prime, so I can just delete it from here. Okay. So now we expect 5, but we got empty stack. I guess that's a thing. Do I have the output? Yes. Okay, this looks better, I think. So we got empty stack, stack pointer 0, instruction pointer 0. Then we push the return address on, which is so the return address is 2, that is correct. Stack pointer is still 0 and instruction pointer is now 3 because that's a result of call. So call jumped into the function here. Then the function does a push. So push is that. I don't know why stack pointer is still 0. Oh, because that's what we're coming back to. So we now have 5 and then 2 on our stack. And then return doesn't seem to be doing anything. So return is getting an empty stack. Okay, but we know that the stack has got 5 and 2 on it, and we know the stack pointer is 0. So if we go and have a look at return, return. So first thing it does is it pops the stack. Oh, let's draw this. Something made a funny noise there. Don't know what it was. I hope everything's still okay. Clear that. Okay, so we know that the stack contains 5, its head, and then 2 as the tail of the list. We know that the stack pointer is 0 and the instruction pointer we don't care about yet. Instruction pointer is right at the end. Okay, so that's what we got. Then we call pop on the CPU stack to get the result and the new stack. Okay, so after we call the first pop, we can say res is equal to 5 and our new stack is just the value 2. Okay, then we call return. I don't really like this return, but anyway, it calls jump first of all. So P is 0 in this case, and S is a stack containing the single value 2. So it shouldn't match this. We should not get empty stack at this point. However, if I think I see what's happened here. So you come to here, P is 0, S is the stack containing 1, so S is greater than P. So we return the new stack, which is truncated. So the length of S is 1, P is 0, So we're going to drop one element out of our stack, and we don't want to do that. So let me change that to greater than or equal to, so we can drop 0 things out. And up here, I'll change that back to a new stack. Okay, and I'm going to rerun my test. We're getting closer. Expected 5, but got unrecognized instruction 0. 0 is halt. So, oops. Back in VM. Halt is 0, so step prime. I need to add something for, oops, if the instruction is halt, then we have step halt prime P in CPU. So step halt prime, I'm just going to update this, and I'm going to return either VM error or that, but we don't actually return any errors, so it's just going to be right of that. Why does it want the program? It doesn't want the program. That's fine. And then I'll just delete it from up here. I'm just slowly going to kill off step as I move instructions over. So I run the spec again. It runs forever. Okay, I guess that's not right. So right, CPU halted, true. So it should be returning C in this case because we're right. And halted should be set to true. And up here, if halted is true, then we should stop. That doesn't seem to be happening. And this seems like the easiest thing in the world now. So we call step halt, we take the CPU and we set halted to be true, and that's the only change we're making. So why would that not stop? Back up here, we have this to be our new CPU, and then we go again, which should be here. Let me just check we're hitting this. So I'm just going to temporarily set this to be left empty stack. Not in scope. Can we make that be in scope? Do that. Yeah, I can. Okay. So if we run it, it should exit empty stack. It does not. Okay. So it's nothing to do with halt. So it'll be something in stepret. draw this again. So we knew from previous experience that 5 and that stack pointer this time should be set to 1, I believe. So we take result, set to be 5, which is head list, oops, and we pop that off. So we're left with a stack of size 1, single value 2 in it, stack pointer should be 1, and result we stored for later. Okay, so we call step ret CPU stack pointer should be 1, I believe. And S prime should be stack only containing 2. So jump. Stack should not be empty. So we should come into here. This is set to 1. S is a list containing a single element. So is 1 greater than or equal to 1? Yes, it is. So we go right up to truncated stack. And the truncated stack is dropping the difference. So 1 minus 1 is 0. So we drop 0 elements off S. So it should just be the stack. So a list containing the value 2. Then we call pop. And pop is giving us back the first thing on the list, which is value 2, and then an empty stack. So now this is the empty stack, and this is the value 2. So the value 2 and an empty stack. So then we set the CPU IP to 2, which should be halt. And the stack is 5 pushed back onto an empty stack. So it should just be a list containing the value 5. We should fix the stack pointer, but I haven't done that yet. But that shouldn't break this. So what else could we do? If I just go into here for a second, instead of just popping continue as normal, I think I might say do the jump, and then I'm going to say left empty stack. Express this warning by what? No. Express this warning. Okay, by just saying it to nothing. Okay, so now I have a run. I'm hoping that it will fail because we get empty stack back. It's not failing. We're not even getting there. So is something going wrong in jump? Nope. It's back to be the way it was. Maybe this is not the one that's failing. So if I get rid of the rest, the other 2 of these, what happens then? Oh, still stuck forever. it this one that's actually problematic? No, something else somewhere is broken. That's really annoying. I really need to work out how to run a single command. Oh, you can control C it. I guess that's good. What else might be problematic here? Maybe the stack spec. Delete. No, delete. For goodness sake. Delete. Delete. Does that work? No. It's really annoying. I just want to not run a test. How do we do nothing? What's the type of spec? Type. Oh, interesting. What are they coming out of the test? It's not even this one, is it? It is not. Okay. What specs we have? Got VM spec, Calci spec. Oh, very confused now. Right, to get rid of those, but let's try it again. Running forever. Okay, I'm very confused. So step ret is only called from exported, and it's only called from here. And this step prime is called from, so it's called from run trace. I wonder if that's called from anywhere. Nope, only from the VM spec. I'm so confused now as to what is looping forever. What I changed was in call and return. So this one I previously made it go bad, by saying I did that before. Did that kind of work? Nothing's kind of working anymore. No. Yeah, it's intimated in here, I think. I don't know when I last changed this. That could be right. No, it could be left. That's easier to type. Left. Empty stack. I'm so annoyed because I don't know what's gone wrong. Let's see that code at all. Okay, very confused as to why none of my specs are running. Very confused why none of my specs are running, he said, after deleting halt from step. Right, okay. Let me just put halt back to where it was. Okay. Let me leave it with 2 halts for a second. Step halt is just a new CPU, so there's no write. Okay, the reason it's not halting is because I removed it from the other version of run. Okay, return just works. It should have got 5, but it gets write 5 in an empty stack, which is the correct answer. So now back in spec, I can say vm.run prime or program should be 5. And what? Turn just works. I thought run prime would give me the result. So run prime is show pop. Okay, so hang on. If we have an error, then we show the error. Otherwise, we'd hit the stack. And we show popping it. The result, final CPU is run it until it stops. And the result is, wouldn't match that, so we should match this. Just pop it and show it. Oops. save all. In case I didn't save all my changes. No, still got a problem. I don't know. I'll look at why the result is wrong, but so why it's not printing it, but it is at least the right result. So my call and return is working. Okay, it's not the session expects of today. I didn't actually fix many of the instructions, but I did get call and return working finally, which I guess is good because it's taken me ages to make that work. Okay, thanks for watching along. Next week I will do more things. I guess I'll try and work out why we're not showing the result properly, and then I'll get rid of step and move everything to step prime, or move everything into this signature where we return the error. Cool. Thanks for watching along, and hopefully see you next week. Bye.